Hi, today I am going to discuss about placement. Placement is the process of placing standard cells in the rows which are created during floor plan stage. The goal is to minimize the total area and interconnect cost, that is making the design routable. The quality of routing is highly determined by the placement. Placement becomes very critical in lower technology nodes. The inputs for the placement stage are gate level netlist, floor plan design, design libraries that are physical as well as logical libraries, design constraints and technology file. Placement is the process of finding a suitable physical location for each cell in the design. Placement is performed in two stages. One is coarse placement and second is legalization. During coarse placement, the placement tool determines an approximate location for each cell according to the timing and congestion constraints. The placed cells don't fall on the placement grid and may overlap with overlap with each other. Large cells such as RAM, IP blocks acts as placement blockages for smaller cells like standard cells. Coarse placement is fast and is sufficiently accurate for initial timing and congestion analysis. The second stage in placement is legalization. During legalization, placement moves the cells to precisely legal locations on the placement grid and eliminates any overlap between cells. The small changes to cell locations cause the length of wire connections to change, possibly cause new timing violations. Such violations can be fixed by incremental optimization. For that, for incremental optimization, we can take an example that by resizing the driving cells, we can we can fix that timing violations. The placement opt command is recommended for performing placement in most situations. This command performs coarse placement, high fan-out net synthesis, physical optimization, and legalization, all in single operation. In certain applications, you might want to perform placement tasks individually using commands such as create placement and syopt. Uh, for greater degree of control or to closely monitor the results as they are generated. In placement process, placement tool considers possible trade-offs between timing and congestion. Timing considerations bring cells closer together to minimize violence and therefore the wire delays will be reduced. On the other hand, the occurrence of congestion draws cells further apart to provide room for connections. Congestion cannot be ignored and entirely in favor of timing because rerouting wires around the congested areas will cause an increase in wire lengths. That will increase the wire delays, thus defeating the value of close placement. In the placement opt, the congestion switch is used. This congestion option causes the tool to apply more effort to congestion removal, resulting in better routability. However, this option should be used only if congestion is expected to be a problem because it requires more runtime and causes area utilization to be less uniform across the available placement area. If congestion is found to be a problem after placement and optimization, it can be improved incrementally with refined placement command. Timing area congestion optimization can also be done incrementally with synopt command. The area recovery option of the placement opt command allows placement tool to recover chip area where there is extra timing slack available. For example, it can resize cells smaller in timing paths where there is a positive timing slack. Placement is typically done before clock tree synthesis, so the clock network is ideal and doesn't have a clock buffer tree available for accurate clock network timing analysis. To get more accurate timing results, you should use the some commands as those used in synthesis tool to specify non-zero latency, uncertainty, and transition times for the clock network. This is about placement. Thank you.